So I'm looking at this.
Okay, guys. So, lesson 4.4. We are factoring. All types of factoring quadratic equations. All factoring that you would have seen at some point or another in Algebra 1. We've got to go back and review. It will be important because when we get to the second half of Chapter 4, I think it's even lesson 4.5, is solving equations using factoring. So if you don't remember how to factor, you're not going to be able to solve equations factoring. And there's a lot to do with that. Okay? So, as we look at example 1, notice example 1 is factoring expressions of the form x squared plus bx plus c. You'll notice there's no a right now. We'll talk about that later. So it's how do we factor when it's a 1x squared plus bx plus c. So as we look at a, it's how do we factor x squared plus 9x plus 20.
No, thank you.
No, thanks.
Oh, pass.
What do we remember?
C's?
Mario
Mario.
Yeah,
Mario.
I just don't actually.
You don't have to explain it. Just say like how you do it. That's okay. Okay.
Yeah, it was 2 years ago.
Shut up.
Yeah.
So here's my hint. If this might trigger some memories.
Yeah, I know.
X squared plus 9x plus 20 is going to factor into two parentheses.
Oh,
Wait.
Oh, wait, I remember this.
Yeah.
It's the foil thing, right?
That's what
I call it unfoil. It's unfoiling. Because we're not going to foil, it's already foiled together. We have to unfoil it.
Oh, well.
Kyle, you got it wrong.
See, this is my thing, okay? Mario may not want to talk to me, that's fine. But here's, if I give you this hint of two parentheses, do we remember some stuff?
No.
No.
Okay. Okay. Next piece. What goes in the beginning of each parenthesis?
X.
Okay, so because right here is x squared. X squared can be broken into x times x.
I knew that. I did know that.
Okay, see, there's pieces you remember. We just have to pull it all together. Now, and that's why example 1 right here is only with 1x squared. We're not getting fancier than that right now, just with a 1x squared. So, now we have to figure out what two numbers go in there, because these are x plus or minus a number, x plus or minus a number. So how do we figure out the numbers?
Greatest common factor.
What?
That was a guess.
Not greatest common factor.
When you take the greatest common.
I just.
We have to use the 9 and the 20 to figure it out.
I say they can't explain them.
I just know.
Well, you kind of are plugging them in.
So we need two numbers that give me a product of 20. And 20 is my C value. And those same two numbers also have to give me a sum of 9, which is my B value. Now, I'm using those fancy math words of product and sum. Okay, so if you're stressing about you don't like my words of product and sum, when I say two numbers that give me a product of 20, I really mean two numbers that multiply to be 20. Okay, and when I say two numbers that give me a sum of 9, they add to be 9. Okay, so feel free when I throw in the words product and sum to really say multiply and add. Now, okay, some of you at this point, you have your numbers, right?
Yeah.
Piece of cake,
Yeah.
you know what numbers.
Yeah.
Now, if you don't know the numbers, here's the process I follow. Okay? For those of you that are saying, yeah, I don't know, for some of you the numbers are just instantly there, aren't they?
No.
For the rest of us, let's talk about it. So when I talk about numbers that give me a product of 20, so numbers that multiply to be 20, We can go through and make a list when we need to. I always start with 1. 1 times what is 20?
19.
What?
1 times 20 is 20.
On purpose.
Then I move on to 2. 2 times what is 20? 10. Then I move on to 3. 3 times what is 20? And you're giving me crazy looks. If you grab the calculator and do 20 divided by 3, you get a decimal, which means 3 does not go into 20. So then I skip 3 and I move on to 4. 4 times 5 is 20. And then officially, if I'm making my complete list, I would then go on to 5 and I would say, oh, but we just used 5. So this is my complete list. Which pair of those numbers that multiply to be 20 also adds to be 9?
I remember this.
4 and 5.
Exactly. So we used the
Okay?
Good for you. I would like to forget it.
You guys are chatty today. Okay,
It's a Wednesday.
so now, okay, let's focus here. The 4 and 5, positives or negatives? There's no negatives in this problem. So there's your clue. X plus 4 and X plus 5. Emma?
So, this may be a good question, but how do you know that you need a product of 20 and a sum of 9 and not like a sum of 20 and a product of 9?
Because it's always going to end up to be a product of the C term. So the number that is by itself that has no variable, please listen, it's always going to be a product of that number. And it's always going to be a sum of the number that's with the X. Okay, that's just, and I can show you a little bit about that here in a moment. At this point, folks, X plus 4 times X plus 5 is your answer. We're done.
Yay.
Now, my question to you, though, is, I'm not saying you need to every time, but I want to on this first one. How can we check this answer? FOIL or distribute, right? As in, multiply it back together. If I multiply it back together, and this might help kind of with Emma's question a little bit too. First, X times X is X squared. Outsides. X times 5 is 5X. Insides. 4 times X is 4X. And last, 4 times 5 is 20.
I remember that part.
If I clean this up, 5X plus 4X is 9X, and that takes me back to the original problem. Now, I'm not saying you need to check every one of them, but I'm just saying that that is a check. And I don't know, maybe if that helps like answer Emma's question a little bit more of, okay, how do we know which is which? Well, these two numbers that we multiply are always going to provide my C value. When we multiply them by the X's, that's when we have the sum. Thank you. Okay, Landon?
Is the order of the 4 and 5 matter?
It is not. So I happen to write X plus 4 in my first parenthesis, X plus 5 in my second parenthesis. If you put X plus 5 and then X plus 4, that's fine. And guess what? Math Excel doesn't care either.
What?
Wow.
It's crazy. Math Excel, you can put it in either order. So, okay. Other questions on this one? Are we a little less lost on this first set now? Is it coming back to us? Okay. Because that's what I need. I need this. This is a huge Algebra 1 concept.
Really?
That is huge in everything we do from here on out, folks. We're using this in Algebra 2 in Chapter 4, but guess what? It's going to come up other times throughout the year. It comes up in pre-calc. It comes up in calculus. It is just expected once you get past here. Okay? So we've got to know how to do this. So, okay, I'm ready to talk B. X squared plus 14x plus 40. What's my answer going to look like? It's going to look like two parentheses. X squared breaks into x times x. How do we figure out these numbers here? Two numbers that give me a product of 40. And if you don't like my word product, you're substituting in there multiply. And they give me a sum of 14. And if you don't like my word sum, you're saying add. Now, if you can come up with the numbers just by going through your head, that's fine. You do not have to make a list. Don't tell them to me yet.
Darn it.
Because here's the deal. Do even the best of us sometimes run into ones that they just aren't obvious.
Yes.
And there are always those situations where, some of you had 4 and 5 from the get-go. It was a piece of cake. Sometimes they just don't magically appear. And so this is where I teach, okay, what's the process I can do? And so this is where I say, okay, how can I make a list? I always start when I'm making my list, this way I don't leave anything out, with 1. 1's always an option. It's 1 times 40. And then I just go up numerically. So after I try 1, 2. 2 times what is 40? 2 times 20. And then I try 3. And I say, what? And then I grab my calculator and say, okay, what's 40 divided by 3? And I'm like, oh, it's a decimal. No wonder I don't know it. So then I skip 3. And then I say 4. 4 times what is 40? 10. And then I'm going to say 5. 5 times what is 40? 8. And then I'm going to say 6. 6 times what is 40?
6.67.
Okay, 40 divided by 6 gives me a decimal, so I skip 6. Then I try 7. 40 divided by 7 gives me a decimal, so I skip 7. And then I say 8, and then I say,
5.
but I already used 8, so I'm done. I have all the possible options. Okay, so that's how I teach making the list here. Are we okay with that?
Yeah.
Now, again, you don't always have to make a list. Did we come up with a pair that works?
Yeah, 4.
Okay. 4 and 10. You want 4 and 10 or 10 and 4?
4 and 10.
72.
Or does it matter?
It doesn't matter.
Doesn't matter.
That always
Okay.
sounds better.
If it multiplies to be positive and adds to be positive, both signs are positive. And I think, I don't know how Mr. Voth would have taught it. I do know a little bit about how Mrs. Rogers teaches it based on what other students have said, and I think her and I teach the signs slightly different, like how to decide what sign. So we'll talk about that as we go through. I have no idea how Mr. Voth taught the signs though. So
I didn't remember anything with his class at all.
okay, C, x squared plus 14x minus 72. It's of the form 1x squared plus bx plus c, right? So, assuming it factors, I know my answer is going to be broken into 2 parentheses. I know they're going to be x and x. I won't say x plus and x plus this time because there's a minus thrown into my problem. So either one or both of my signs are minuses. I figure them out here in a little bit, and I think this is where Mrs. Rogers teaches it slightly different. So, okay.
Where it matters. So, like, what order your numbers are.
Well, see, I don't teach because I don't teach that it matters which order your numbers are in. I teach you just have to put the correct sign on the correct number. So this is where I think Mrs. Rogers and I teach it slightly different.
I don't even remember. You might have to.
Okay. Regardless, what is the next step? We need two numbers that give me a product of negative 72 and a sum of 14. Now, when we talk about two numbers that multiply to be a negative, what do we know about two numbers that multiply to be a negative?
One's positive, one's negative.
Okay, I know, however this works, that I'm going to have a positive and a negative. Now, I still go through and make my list like normal, and then I come back and figure it out, later. So if we do numbers that multiply, and I don't worry about signs right now. Different teachers teach it different. 72. So 1 and,
Negative 7.
I'm just going to say 1 and 72. I'll talk signs in a little bit. 2 and, not crap,
36.
36. There we go. 3 and, there's got to be something.
Oh, wait, sorry.
24? Okay. 4 and,
8.
I'll go none on that one.
8.
Oh, is it? 4 and 18. Oops, sorry. Oh, 4 and 18. That's all right. Your teacher overlooked it too. Your teacher was going to mess us up. 5 and,
Nothing.
okay, 5's a nothing. 6.
12.
12.
6 and 12. 7,
Nothing.
8. And if you see 8 and 9, and the next number we want to try is 9, we know we're done.
7.2.
Okay. Now, here's the deal. We already said that we need a positive and a negative number. What happens when you add a positive and a negative number?
Oh, which one?
Depends on what number is negative.
But, okay, it does depend on which number is positive or negative, but when you add a positive and a negative, do you actually end up adding them?
No.
No. We end up subtracting. So when we talk about we want two numbers that give me a sum of 14, keep in mind one of them could be negative. And one of them will be negative here. So these two numbers aren't going to add to be 14. In this case, they're actually going to subtract to be 14.
4 and 18.
So then which pair do we need
4 and 18.
that your teacher almost messed up on? The 4 and 18.
We might have not solved this one.
I would have been really confused. Okay. Now, with 4 and 18, if it multiplies to be a negative 72, we need a positive and a negative. How do we get a positive and a negative to add to be a positive?
Smaller number has to.
The small number has to be negative.
Smaller number negative, larger number positive. Because if two numbers add to be a positive, bigger number has to be positive. If they added to be a negative, bigger number has to be negative. And so, based on the way I have taught this, one of my parentheses is x minus 4. The other parenthesis is x plus 18.
This is.
Did she keep saying consistent? I did too.
Okay?
Yay. I did it.
Coming back to us a little bit? Sure. Okay, or if it's not coming back to us, are we okay with what I'm teaching?
Sure. Yeah. Backwards.
Because, needless to say, there's a reason I did not just skip this lesson, right?
That is a good reason.
Exactly. Okay. One more in this section. X squared minus 11x plus 30. What are you writing down? I don't know if anyone went ahead and wrote parentheses or not, but you can.
I did. That's what you said. You said
Okay.
right now. I said.
And some people are writing the parentheses and the x and x. Some of you went ahead and jumped to your list of numbers. Or some of you just already wrote your answer down. You didn't even do that. Whatever. Product of 30. Sum of
Negative.
negative 11. Okay. So, I need a list of numbers that multiply to be 30. 1 and
30.
30. 2 and
2 and 15.
15.
Oh my gosh.
Here's a hint. If your teacher's already written down 2,
That's like the easiest.
something works. 3 and
10.
I feel like 1 would be the easiest.
10.
one.
Yeah.
4 and
Nothing.
nothing. 5 and,
6.
and then we say 6 and we're done. Okay.
So it's
Now, we didn't talk about signs here. If this multiplies to be a positive, What do we know when two numbers multiply to be a positive?
They're both
Negative.
They're both negative.
They're the same, right? They're either both positives or both negatives. Mine need to add to be a negative here, which means, can I have both positives? No, we're going to have both
Negative.
negatives here. Okay? So, if you want, we know it's going to be x minus and x minus. Okay, I lean against the screen. Which pair works?
5 and 6.
5 and 6. And then we just have to say that they are
Negatives.
-5 and -6. And you can check that, right? -5 times -6 is positive 30. What's -5 plus -6?
Negative 11.
-11.
Okay. When do we use the in that
You guys
When do we use this?
Yeah.
When we go to solve these equations in lesson 4.5.
Fair enough. I wasn't.
Today we are just factoring. And then after lesson 4.4, we'll take a break and we'll quiz. Then when we come back, 4.5, we are solving. So,
We'll use this on
okay. We ready for example 2?
I mean, if you're ready. I know. Are we?
I'm there. Okay, example 2, so bottom half of this page. Notice the forms are different from up above, right? Up above, it was always x squared plus bx plus c. And it was always a 1x squared plus bx plus c. Down here, we're specifically talking about factoring
The greatest common.
GCFs. So factoring a greatest common factor. So as we go through, and technically when we were up on the top section, our first question, anytime you're factoring, should always be, is there a GCF? Always, always, always. Okay? So from here on out, that's always going to be my first question, assuming I remember, is there a GCF? So, on A, 6n squared plus 9n. Is there a GCF? Is there something that 6n squared and 9n divide by? 6 and 9 both divide by 3?
Yeah.
Anything bigger? No? Okay. 3. So we know there is a GCF of 3. Do they have any variables in common?
What is that? N.
So are there any letters that both terms have?
N. Well, no, because
Well,
one
no,
is
not
a
technically
square.
because there's an n squared.
Okay. But do they both have a factor of n?
Yes.
Yes, I can divide both terms by an n. As long as they have n to the first or higher, any power, we can divide by an n. Okay? So our GCF here is going to be 3n. Now, when we factor this out, we're going to put the 3n out front, and then we have to fill into parentheses what remains when I factor that 3n out. Which basically means I'm going to take each term and I'm going to divide it by 3n. That's what we're doing here, is we're dividing both terms by 3n. So now we have to review our exponent rules along the way today too. So, okay, 6 divided by 3 is 2.
2n plus.
N squared divided by n.
N.
N. Officially, when you're dividing and there's exponents involved, you keep the base and subtract the powers.
Power.
So if you have n to the second divided by n to the first, 2 minus 1 makes it 1. So we say 2n. Carry down your plus sign. 9n divided by 3n.
3.
9 divided by 3 is 3. And the n's in this case will cancel. And in that case, that's all we have to do.
Yeah.
Okay? Don't get into that habit of, oh, GCF and we're done. You still will always need to check, is there other factoring we can do, but 2n plus 3 is just a linear expression. Nothing can happen.
I like this one.
Okay, good point. Multiply it back together to check and make sure it matches up with your original problem. That is a check. Okay, B, 7n squared minus 21. First question, is there a GCF?
Yeah.
7.
7.
7 and 21 can both divide by 7.
7.
Are there any variables in common?
No.
No.
7 has n's attached, but 21?
Does not.
If 21 has no n's, we can't say there's an n in common.
No.
So we are just going to have a GCF of 7, which means if you need to write the visual in, it's that I am dividing all terms then by 7. 7n squared divided by 7.
N squared.
N squared.
Let's do with n squared minus
3.
21 divided by 7 is 3. Okay, we can multiply it back together as a check. Make sure you don't want there to be any remaining GCF here. If there's any remaining GCF, we didn't get the biggest. Okay. Okay. C. What is our first question always?
Greatest common factor.
Is there a GCF? Is there a greatest common factor? And guys, you have calculators by your sides, right? So there's no excuses of, I don't know what the biggest number that goes into all those is. Because you grab your calculator and you use the calculator, right?
Exactly.
4.
Just 4. Just answer 4.
Okay, and here's what I would say. These are all even. So I know there's a minimum of 2.
Yeah.
My brain says, well, I know 4 goes into 4 and 20. So what am I going to grab the calculator and check if I'm not sure?
Divide by 50.
Does 56 divide by 4? And does it?
Yeah. It's 4.
Okay, so we're going to put a 4 out front. And that means I'm dividing each of these terms by 4. Wait, is it 4 or 4x?
It'd be 4x because there's 2 common.
No.
It'd just be 4 because one of them doesn't have 1 in common.
Okay,
Sorry.
there's no x on 56. Sorry. So just 4. Okay. 4x squared divided by 4 leaves me with
X.
x squared. Carry down the sign unless you have reason to change it. 20x divided by 4. 5 what? X. Minus 56 divided by 4? 14. Now I've got to start asking the question, are we done?
No.
Yeah, I thought so.
We got our GCF.
But you want to check.
Is there more factoring
Yeah.
that could possibly be done?
I don't think so.
Your
No. 4 does not go in 5 does not go in
Okay.
14.
So we're done with our GCF.
Are we wrong?
We're done with our GCF. We're good with our GCF. But notice what's in the parentheses looks like the top of our page. Is there another step of factoring we can
Yes.
No.
Yes, I knew it. I knew it too.
do? Okay.
distribute your 4 into everything.
If we distribute our 4 back, we're just right back to the original problem. We don't want to undo ourselves.
I want to do
So here's what you've got to do, folks.
No.
You need to check, is there a product and sum that works for the values inside the parentheses? Maybe there is, and maybe we need to factor another step, or maybe there's not, and we're done. But you always need to check. So, what we're checking here is a product of what?
Negative 14.
A product right here of negative 14 and a sum of
5.
5. What numbers multiply to be 14?
2 and
1
7.
and 14.
1 and 14 or 2 and 7? What could maybe work depending on signs?
2 and 7.
Seven.
2.
7 minus 2 is 5, isn't it? So
Yes.
this might work.
It's a win.
Let's try it.
Now you can
If it multiplies to be negative, I need a positive and negative. I need opposite signs. When I add opposite signs, they actually subtract, right? Can 7 minus 2 give me 5? Yeah. So which number's positive, which number's negative?
Well, 2 is positive, 7 is 2, so.
No, 2 is negative, 7 is positive.
Yeah.
7 positive, 2 negative. Because I need a positive 5x, right?
Right.
If I need a positive 5x, I need my bigger number to be positive. So when I write this final answer, first of all, this 4 out front,
To come from both of the
Carries
parentheses?
down.
it just carries down out in front of the problem in general.
But does it
And then, so it just goes in front of the first parenthesis.
haha.
Then we got 2 parentheses, because we were able to factor product and sum. X squared is
X plus
x and x. And what do we say?
Negative 2.
A minus 2 and a plus 7.
wow.
Okay, one more. D. What's my first question? Is there a GCF?
9.
9, 9, and 18 all divide by 9. Are there variables in common?
No.
No. 18 does not have an x, so I can't say x. So we're going to factor out a 9. 9x squared divided by 9 leaves me with
X squared.
x squared. Plus 9x divided by 9 leaves me with x. Minus 18 divided by 9. 2. And I don't know. Do you guys want me still writing in divide by 9, divide by 9, divide by 9?
I did.
If you're past that point, that's fine. If you still want it, go for it. Okay. You gotta ask us every time. Am I done?
No.
We need to at least try to factor a little farther, don't we? No guarantees it'll work, but we need to try.
There's only one thing we can list.
A product of what?
2.
Negative 2. And a sum of the invisible 1.
Can you make a list? It'll be really helpful.
Okay, we can make a list just for you, Noah. What multiplies to be 2, Noah?
1 and 2.
1 and 2.
1,400.
Okay, so how do we multiply to be a negative? Not both negatives.
Negative
A positive and a negative. How do we make it add to be positive 1?
Negative 1 plus 2.
Negative 1 plus 2. So does it work?
Yes.
It does. Carry your 9 down out front. 2 parentheses. X and X. What goes in those parentheses?
Minus 1 plus 2.
X minus 1, X plus 2.
Yay.
Technically, we can keep going, can't we?
No.
Well, it just means less that we have to get through tomorrow. Okay, here's the deal. In these last couple of minutes, we'll start with E tomorrow, but you do E right now.
I'll do E.
Okay? In terms of homework, you can go ahead and start the homework. You won't be able to finish it because there are some big things we have to talk about on the back. Okay? So plan on that.
What do we do if it can't factor?